All right, welcome to The Explainer. Today we're going to dive into a book that's, well, it's a legend in computer science. It's so influential, so mind-bending, that for decades, programmers have given it this almost mythical nickname, the Wizard Book.
And you know, this one quote really sets the stage. This line from the Foreword of Structure and Interpretation of Computer Programs, or as everyone calls it, SICP. It's not just some pretty sentence, it's really the soul of the whole book. It's telling us that programming isn't supposed to be this dry, technical thing. No, it's more like a magical act. It's about taking our ideas and making them real.
You see, every single programmer out there, I don't care if you're a total beginner or a seasoned pro, is fighting the exact same battle. And that battle is against complexity. As your projects get bigger, they threaten to crumble under their own weight. And that's where SICP comes in. This isn't just another coding manual. You got to think of it more like a spell book. It's packed with these powerful, timeless spells for taming that complexity. So let's dive in.
Okay, so Chapter 1, The Programmer's Spellbook. The whole point of this book isn't just to teach you a new language, it's to completely rewire how you think about programming. Seriously, it's not about memorizing syntax, it's about learning to see the programs you write and the things they do in a totally different way.
The authors, they talk about this idea of an explosion of perception that can happen when you program. It's not just about hammering out instructions for a machine. It's about creating these living, breathing models of your own ideas. You're building these mechanisms that can actually grow and change right along with your own understanding of a problem.
All right, so how do we actually start to fight back against that complexity we talked about? Well, the very first spell the book teaches us is all about how we build processes. And the key technique here is something called procedural abstraction.
So what is that? Procedural abstraction. It's really just the art of creating these little computational black boxes. Think of them like spells. Each one does one specific thing, and it does it really well. And here's the beautiful part. Once you've made one of these black boxes, you don't have to care how it works ever again. You can just use it. You can grab it, combine it with your other spells, and build something way, way more powerful.
In this example, with the square root function, it makes that whole black box idea super clear. Instead of writing one giant, confusing chunk of code to find a square root, you break it down. You create these smaller, simpler spells. One that asks, is this guess good enough? Another that says, okay, let's improve the guess. And a third one that just puts those two together over and over until it gets the answer. See? We're building this powerful SQRT spell from tiny, easy-to-understand pieces, and we never get bogged down in the complexity.
And this is absolutely crucial. Hiding those details inside the black box is what prevents total chaos. The names you use for things inside one of your spells, they don't leak out and mess with your other spells. It's like having soundproof rooms. This is what lets us build enormous, complex systems without everything breaking. These abstractions, they create these clean boundaries. They keep our spells from, crossing the streams.
Okay, so we've got a handle on abstracting the actions in our programs, right? The procedures. But what about the stuff, the data that those procedures work on? This is where SICP starts to get really, really wild. It wants us to completely rethink what data even is.
And this analogy from the book's foreword is legendary for a reason. It asks a really simple question. How should we build our programs? Are we building pyramids? These huge, static monuments that are impressive but impossible to change? Or are we building living organisms? Things that are dynamic, that can adapt, that are made up of smaller living parts that all work together. And SICP, well, it's all about building those organisms.
So that brings us to the second big spell, data abstraction. And it's basically the same idea as before, but for our data. Just like we hid the details of how a procedure gets its job done, we now need to hide the details of how our data is put together. We create this wall, this barrier that separates how we use the data from how it's actually stored deep down in the machine.
So what's the secret sauce? What's the glue that lets us build these data organisms? In Lisp, it's something almost ridiculously simple, a pair. Just two things stuck together. But the real magic, the part that makes this so powerful, is something called the closure property. And all that means is that the glue you use to stick simple things together can also be used to stick the combined things together. It's exactly like Legos.
The little bumps that let you connect two bricks are the same bumps that let you connect a whole spaceship you built to a landing pad you built. It lets you build unbelievably complex stuff from just one super simple ingredient.
Okay, let's take a breath. We figured out how to abstract our actions and how to abstract our data. We can build complicated behaviors and complicated structures. Now we get to the final boss. The biggest, most powerful, most mind-bending idea in the entire book.
And it starts with a question. What if the very tool you're using, the programming language, is actually part of the problem? Just think about that for a second. What if the language itself is the thing creating all the complexity? What if its rules, its limitations, are actually holding you back?
The answer? You build a new one. This is it. This is the ultimate destination of the SICP journey. The most powerful way to manage complexity isn't to just get better at using your tools. It's to build the perfect tool for the problem you're trying to solve. The programmer is no longer just a programmer. You become a language designer.
And this has a name. This is the final, ultimate spell. Metalinguistic abstraction. It sounds fancy, but the idea is simple. If you're trying to model an electrical circuit, why are you messing around with generic variables and functions? Why not just build a language where a resistor and a capacitor are basic building blocks? When you build a language that speaks the language of your problem, your solution just clicks. It becomes clearer, cleaner, and unbelievably more powerful. So, you might be wondering, why on earth are we still talking about a computer science book from the 80s? It's a fair question. And the reason is the magic in this book. These spells, they have nothing to do with any specific technology. They are timeless. They're about how we think. So if you only remember 3 things from the Wizard book, make it these. First, think in layers. Always be building powerful things out of simpler things. Second, your program should be a perfect mirror of your idea. If the code is messy, it probably means your thinking is messy. And third, the ultimate move. Programming is language design. The best way to beat complexity is to invent the perfect language for whatever you're trying to do. That's the whole shebang. That's the real magic. Now yeah, the book uses a language called Scheme for all its examples. But honestly, that almost doesn't matter. The lessons we've talked about, abstracting procedures, abstracting data, and especially building your own languages, these are universal truths. They apply to everything. It doesn't matter if you're writing Python or JavaScript or Rust or some language that hasn't even been invented yet. This way of thinking, it's timeless. And so, I want to leave you with this one last beautiful, mind-bending question from the book itself. What SICP is really telling us is that the goal of programming isn't just the thing you build at the end. The real power, the real magic, is in the tools and the languages you invent along the way. The key to the treasure is the treasure. So the only question left for you is, what are you going to build with it?